Hey everyone, happy Wednesday. Today we are going to do notes just like normal. So I know video form is kind of funky. Whoever is showing this right now, if you choose to pause at any point, that is totally fine with me. But I'm going to try and go to pace that is comfortable for everyone. We're just going to go through a couple examples here and all the notes like usual, as we would in class time normally. And then you'll have plenty of time to do the individual homework problems. And again, feel free to work with each other, collaborate on those, but make sure that you've got the Wednesday's homework done for tomorrow once I'm back. All right, let's go ahead and start. A little bit of this, as usual, the notes are designed, is review/preview. So, this is asking me, what operations do I use when combining like terms? Well, we did this on Monday, right? Combining like terms, all we do is add terms together. So if I have 3k plus 6k, I'm adding the coefficients together, right? Or let's say this was negative, then I'd be subtracting these terms together, right? So the operations I'm using are addition and subtraction, okay? So for combining, they're plus, minus. How about distributing? Well, we learned how to distribute yesterday in class, right? That's when we have parentheses and there's some number outside, and we have to distribute that on the inside. Well, remember what happens here. This is a multiplication sign. So the operation we use is we distribute by multiplication. Okay, so just kind of reviewing, remembering what operations we use. So, what comes first? I'm going to move down here, so move along with me. And it says, if a problem has combining like terms and distributing, which comes first? I'm going to tell you right now, it's always, always, always distributing. The first step is to distribute. And why is that? Well, in order to combine like terms, we have to add things together, right? So up here, we have a problem, and I can't add anything together until I get rid of these parentheses, right? And in order to get rid of the parentheses, I have to distribute. Okay? So a little preview of that problem. But hopefully that's becoming a little clearer. And again, you can always email to ask questions or ask me tomorrow in class. But distribution, I don't know why I said that so funky. Distributing comes first. Okay? Always, always, always. And then once we're done with that, we have terms that we can add or subtract together. In other words, combine like terms. Okay, so let's move on to this problem. So this is a little bit of review, right? Basically, this is asking you simplify the expression. This is something similar to what we did yesterday. What do I do first? What did I just say? What comes first, distribution or combining like terms? Distribution, right? So if I see parentheses here with a number in front, I know what happens. I need to distribute that. So I'm going to rewrite the rest of the problem, except distribute that as I go. So I'm going to say 8 plus, here's where the distribution starts. 4 times 10p is 40p. And then 4 times 1 is 4, right? And then I finish up by writing the rest of my problem down. Now, here's where I'm combining like terms, right? First, I'm going to highlight my 8 and say, okay, do I have other like terms? Any other constant numbers? Well, not 40p, not 10p, but 4 is another constant, right? So I'm going to add 8 plus 4. Cool, that is going to be 12. How about, let's go to the orange. I'm going to highlight 40p. Do we have any like terms to 40p? Well, I see 10p. Those both have the variable p, so that means I can combine them. So I add 12 to 40 plus 10 is 50p. So a little review for you. Now, I've just squared it, so you already know I'm done. But how I know I'm done is that these two things are not like terms, right? It cannot keep going. So, this final thing is kind of entering us into the actual lesson today. What does this mean? This says, what does it mean for something to be equivalent? Well, equivalent is kind of similar to the word equal, right? Not the exact same, but it's quite similar. What it means for two things to be equivalent means that they are the same. On a very basic level, you're just saying they mean the same thing, right? So let me give you this. Let's say I said 64. Give me something that's equivalent to 64. And there's many things. You could give me a whole lot of things. I could say 60 plus 4. That's equivalent, right? Those two things are equivalent to one another. How about, let's think of another way. How about 8 times 8? That's 64, right? That's another thing or term that is equivalent to 64. So just thinking of some examples, but keep in mind, there's not necessarily just a single thing that is equivalent to one term, right? Like I said, 60 plus 4, 59 plus 5. There are many, many, many ways to write terms that could be an option of something that's equivalent to it. All right, oops, drawing a line on my sheet. So this is our review/preview. Now, this whole equivalence thing that we just learned, we are going to continue on to truly learn how do we figure out if two things are equivalent. So let's start just with a plain old problem. The question asks me, which expression is equivalent to 5, parentheses 8a? How do I figure out? Well, this is asking, okay, I've got 4 options. Which one is equivalent? Well, first of all, I should evaluate. How do I evaluate? If I asked you to simplify that, what would you do? 5, parentheses 8a. Whenever I see those parentheses, what operation is that? It's invisible multiplication. So really, I could just distribute that and say, what is 5 times 8? That's 40. And then I still have my a. So 40a, do I see that here? Yeah, I see it, right? Those two things are equivalent because all I did was simplify, right? And we know when we simplify, we're not changing anything. It means the exact same thing, it just looks a little different. Okay, so that is our final answer. Now, let's move along to the next one. Notice this looks a little different. There's check marks, but it's really the same idea. You're selecting the expression that's equivalent to 7k plus k. The thing is here, there could be more than one expression, right? Select the expressions, that's plural. It doesn't mean that there has to be, but we want to look at every single one of these options now and see, okay, are these equivalent? So I'm going to go up here to my problem, 7k plus k, and evaluate. Looks like here there's no distribution. I'm going to go ahead and combine like terms. So I have 7k and k. Those are very clearly like terms, right? Both of them have a k. I know that there's an invisible 1 here, a coefficient of 1. So 7 plus 1 gives me what? 8. So I'm left with 8k. All right, so one thing off the bat that I know is 8k is equivalent, right? Because all I did here was to simplify. However, let's keep going down the line. Okay, so I'm going to go down here and evaluate and see, is that also equivalent? This says 5k plus 2k plus k. Are those all like terms? They absolutely are. They all have k's, right? Well, 5 plus 2 plus 1 is 8. So I'm left with 8k. So is that equivalent? It absolutely is. So I'm going to circle it. And the reason is, again, all of these things are equivalent because they mean the same thing. They are all equivalent to 8k, right? Even though they look a little funky, they look different, they're all the same. And then if I keep going down, I'm saying, okay, 7k, definitely not equivalent. But how about k times 8? Well, that's actually really just 8k, which is or isn't equivalent. Definitely is. So in this case, we have more than 2 options, right? There's so many ways to rewrite various things that are equivalent to one another. And we'll continue to see that down the line. So let's move on to this next example. I'm immediately going to go here and simplify. What do? Immediately, I notice parentheses. I got to distribute. So I'm going to say, okay, 2 times n is 2n, and 2 times 2 is 4. So that simplifies to 2n plus 4. Do I see that here? I actually don't. So what I'm going to have to do is go down the line and figure out which one of these matches. So I'm just going to evaluate every single one of these. This is really n times 2 is just 2n. So if I distributed that, this would give me 4n. Is that equivalent to this? No, it's not. I'm going to draw an x. How about 4n plus 2? Well, no, these are not the same, right? 2n plus 4 is totally different. So those are not the same. How about 4n? Nope. How about this last one? Well, really, all this is our original problem except flipped, right? If I distributed this backwards, I would get the same thing. So this is actually our answer. This expression is equivalent to 2 times n plus 2. Okay, so make sure you're following along. If you're a little confused, definitely ask for clarification once I'm back or to your peers. And you can absolutely work on the homework together to clear any miscommunications up. So now let's do another one. We're going to select multiple expressions here, right? Notice we're selecting a couple different expressions, maybe one, maybe more, that are equivalent to this. Now this one's a little trickier, but we're going to do it anyway. What happens here? I know there's a plus sign, maybe some like terms, but first I have parentheses. I got to distribute. All right, what's 3 times 9? 27, G, and then I add 3 times 2, which is 6, right? I rewrite the rest of my problem. Now I can combine like terms. I see 2 terms that have G's in them. So what's 27 plus 3? That's 30, G plus 6. Now how do I know I'm done? No more like terms, right? 30G and 6 do not combine. I already see that off the bat right here, so I'm just going to circle that. This first one is not equivalent, right? 2 is not equal to 6. How about the second one? I already notice, isn't this part just our original problem but flipped? And then we add 3G again? So I think that's equivalent, right? If we solved this out, that would end up being the same exact thing that we got here. How about 6G plus 30? Nope. Up here we got a coefficient of 30, so that's not going to be it. So just the middle two. Okay, so take a moment if you need a second to catch up and write anything down. So keep in mind, whatever it's asking you, sometimes they ask you, choose the expression. So in other words, there's one expression that you need to choose that is equivalent, and sometimes there's more than one. Right? Sometimes there's a lot of ways to write something, and your test or quiz, or maybe me, I want to know if you could choose more than one option. Okay, so let's go ahead and do one more. We're going to do this one. Okay, so skip on this last one, and then we're looking at this. Select the expressions that are equivalent to this. So remember, my first step is let's go and just simplify, right? What do I see? I already see some parentheses. I'm going to distribute. 5 times negative 7 is negative 35z. And then 5 times 1 is 5. Now, can I combine like terms here? I don't see any like terms. I see a z term and a constant term. Those are not the same, so I simply just leave it where it is. Okay, so what happens now? Well, negative 7z plus 5, nope. How about this second one? Well, let's work this out. I'm going to distribute and see what we get. 5 times negative 9 is negative 45z. And then I take 5 times 2. That's 10z. And then in the end, we add 5. Well, it looks like this might be similar, right? Let's combine our like terms. I have 2 terms that have z, and that gives me negative 45 plus 10, which is negative 35z plus 5. How do I know I'm done? No more like terms. That looks exactly the same as my top term. So this is absolutely an equivalent term. This one is verbatim exactly the same, right? I could tell this looks exactly the same as my simplified expression. And then the final one, what we need to do is distribute, right? So what do I see? I get negative 35z plus 5. Is that the same? It absolutely is. So I have 3 different expressions that are equivalent to this original expression. So just keep that in mind. There could be 2, there could be 3, there could be 1. Possibilities are kind of endless. Just depends what you're given. All right, so that is the end of the notes for today. What I'm going to have you do now is the homework is up on the course calendar. So you're going to go there. And again, I don't mind if you're doing this on paper. You can copy those terms up on your paper. You can do them on Notability, wherever you want. But there is a worksheet full of problems. It's called Equivalent Expressions. Okay, so make sure that you're in the right spot finding that. If not, ask your classmates. You guys should know where to find this. And feel free to work together and make sure you get this homework done before tomorrow when I return. All right, you guys, happy Wednesday. I will see you tomorrow.